Hi, my name is Lorissa Humble, and this summer I was a participant in a National Science Foundation REU at Notre Dame in the Center for Research Computing. This summer we've been working on a project that originated in the Kellogg Institute for International Peace Studies. So let me give you a little bit of background on the project. We are conducting an examination of potential triggers to mass killings committed by the state against its citizens using the event coding software Petrarch. More research is needed on the environment and political actions that precede mass killings in order to inform better prevention efforts by policymakers and practitioners. And while some genocide prevention organizations have found some patterns like armed conflict escalation, perceived foreign threats to national sovereignty, abrupt regime change, or challenges to elite political control, there has been a lack of systematic research which could help to predict the circumstances under which a genocide is most likely to occur. This research examines 9 potential triggers, or events with a strong and proximate connection to a mass killing: escalation in armed conflict, spillover of conflict from a neighboring country, new opposition, political party or movement, riots or demonstrations, change in political control or election loss, a coup or attempted coup, cancelled or postponed election or highly contested upcoming election, assassination of prominent individuals, or a change in peace negotiations. For this analysis in particular, we used 2 triggers, triggers 6 and 9, for which the dictionaries that help the software identify the triggers in the articles have been made. Initially, this identification was done through human event coding of news articles gathered from the LexisNexis news article database for 60 countries and for 72 genocides. Looking 2 years prior to the event, these triggers were identified and recorded. This dataset forms the basis or comparison set against which we validate the event coding software pipeline developed by another member of our project's team. After collecting the data via this software, it needs to be analyzed, which is mainly what I have been working on. To find the likelihood that a mass killing will be preceded by these triggers, event coincidence analysis, or ECA, was used to generate precursor and trigger coincidence rates for the event time series for triggers and mass killings. Results indicate that the Petrarch-generated data for triggers 6 and 9 do not differ significantly from the events coded by people. Because designing the dictionaries required us to look at what human coders identified as an event to make it accurate, it was expected the results for ECA would be more or less the same. This gives us more confidence in the tool's accuracy in identifying events with similar levels of precision to human coders. Trigger 9, or a change in peace negotiations, was more common in democracies than either autocracies or anocracies. 0% of mass killings in democracies were preceded by trigger 6, or coups. However, a mass killing in democracies was preceded by trigger 9 14% to 28% of the time during that 2-year window. This means that trigger 9 in democracies was more likely to occur and act as a precursor to a mass killing than in either of the other regime types. Coups were equally as common in autocracies and democracies, and much more common in these regimes than in democracies. They were the most likely regime types to have trigger 6 occur and act as a precursor to a mass killing. To summarize this analysis, the human-coded data from the initial stages of this project and the Petrarch-generated data were not significantly different for these triggers, which gives us more confidence in the tool's validity. The frequency that a mass killing is preceded by one of these triggers varies by regime type pretty significantly, with trigger 9 being far more common in democracies and trigger 6 being far more common in autocracies and democracies. These results show how important it is to consider background variables in trigger analysis, as the probability that a trigger will occur varies quite a bit between regime types. In the future, we will continue to refine and add to the event coding software pipeline. The rest of the dictionaries which enable the identification of triggers still need to be completed and validated against human-coded data. Our ultimate goal is to be able to use this tool to code triggers in more articles than it would be feasible for a human to complete by hand. In addition, the analysis would be more complete if background variables like economic development and region were considered. Thanks to Dr. Brenner, Dr. Regan, Dr. Verdeja, and Angela Chesler for their leadership and guidance on this project.